Today we're going to see how to make a basic fluid simulation in Blender. To create a fluid simulation inside Blender using the default fluid add-on, we need two main components. The first of these is a domain. I'm going to create the cube to make my domain. A domain is the area in which fluid can be simulated by Blender. Once we've created it, we go to the physics settings and we select fluid. We change type to domain. By default, it's going to be a gas domain type, but we're going to want to change that to liquid as we're not doing a gas simulation today. The only other settings we need to worry about for now are enabling the mesh tick box here and making sure the type is on all inside the cache tab. Now we've completed our domain and we have to move on to the flow. I'm going to use an icosphere as a flow, however you can use any basic mesh. A flow is how the liquid enters the domain. Hitting G, I'm going to move the flow on the Z axis to the top of the domain. Now if I go to the top right and hit this little drop down, I can enable X-ray mode, which will allow me to see through the domain until it is baked. Now I'm going to enable fluid on my icosphere and change the type to flow. For the flow type we want to select liquid as we're doing a liquid simulation. Now all the basic components are complete for a liquid simulation in Blender. If we go back to the domain, we can bake in the data. This is a very CPU intensive process. Now we can see at the bottom of the screen our timeline scrubbing through. This is the fluid being baked. If I press escape at any time, I can cancel early to make sure I don't waste time baking in an incorrect fluid simulation. Now if we watch the replay, we can see how the geometry of the icosphere drops down in liquid form and splashes around the bottom of the domain. This is happening because of the flow behavior settings we have set on our flow. If we select it, we look at flow behavior, it's on geometry. If we select inflow instead, there will be a constant stream of liquid coming out from the icosphere. Now we can free all and rebake the fluid simulation to see the changes. It's going to take a lot longer for this second simulation. This is because of the sheer volume of fluid that's going to be simulated now that there is a constant stream entering the domain. Now even though this is a fairly low resolution simulation still, it looks quite impressive. We can see a constant flow of liquid coming out from our icosphere, splashing up the sides of the domain. However, if we zoom in and look closely, we can see that the shading on the liquid seems to be quite low resolution mesh with not many polygons. If we right click, however, we can shade smooth and this will solve the problem and allow it to look a lot more natural. Next, I'm going to create a basic blue material for my liquid. To change the material on the liquid, you need to add a material to the domain, as the domain becomes the liquid once it is baked. I'm going to make the material blue, I'm going to increase the specular, I'm going to lower the roughness just to make a shiny blue liquid. One other component to fluid simulations in Blender are effectors. When you make an object an effector, it will affect the flow of a liquid. Here we can see I have created a small monkey head, which is a basic mesh in Blender, made it an effector and animated it to go left and right through the fluid simulation. This is how you could create a container for your fluid, or how you would make any other object in your scene interact with the fluid and not just phase through. Resolution division allows you to make a more accurate fluid simulation with a higher resolution of the fluid, smaller chunks and smaller particles, however longer render times. Viscosity does what you'd expect and allows you to make a thicker liquid such as honey. Thank you very much for watching. Please drop your questions in the comments.